we're going to take step by step as we've done in the past with dimensional analysis. This is the point in the lesson where we apply dimensional analysis to chemistry quantity problems, or chemistry conversion problems, okay? In this case, I want to find out how many atoms, okay, are in 177 grams of carbon. So I'm going to make a conversion here. I'm giving you 177 grams of carbon, and you need to use dimensional analysis to calculate how many atoms of carbon I have, okay? There's a couple fun facts we got here. The fun facts are 1 mole of carbon is 12 grams of carbon. 1 mole of carbon is 6.02 times 10 to the 23rd atoms of carbon, and 1 mole of carbon is 22.4 liters. Okay, and this problem might look a little intimidating right off the bat, but I just want you to know, if you follow the 4 steps we've introduced the other day, it should not be a problem. Now, the first step is to check out the givens. I've been giving you 177 grams of carbon. So we're going to start the problem off with 177 grams of carbon. Awesome. And I also know that the other given in the problem is how many atoms. I know this problem is going to finish over here, and it's going to finish in the unit known as atoms. Awesome, guys. These conversion factors down here, they're going to fill up what's in the middle here. I'm going to put them in the middle. What is going to guide the whole problem is the units. I'm starting in grams, and so even if I'm a little confused of what to do, I should know that I need to cancel out the grams of carbon up here with grams of carbon down below. Your job is to look into the conversion factors for the unit grams. And you find it right away right here, 12 grams. And that's the number I'm going to use, but that number is actually glued to this number, 1 mole. So wherever 12 grams of carbon go, 1 mole goes as well. So let's fill this in. We have 12 grams of carbon and 1 mole of carbon. Now grams is canceled out. I'm in the unit mole now, and the problem stops when the unit on the top matches the unit over here. Now, I'm going to go down here, guys. This is gone. I've used it up. I have 2 more choices for conversion factors to get me through the problem. Okay, next one. Well, if mole is on top, then I need to have diagonally downward, down here, a mole. So I'm looking for that unit again, okay? And I see it here and here. So really the question is, which one of these 2 will lead me closer to the unit atoms? And I'm just going to key over here. There's my word. I'm looking for that. So I'm looking for that keyword. And so I'm going to use the second one here, 1 mole of carbon. 1 mole of carbon is going to have 6.02 times 10 to the 23rd atoms of carbon in it. I crossed the unit mole off. And now the problem is actually done. It's done because the unit atoms matches the unit over here, and it is not canceled out. I know I've reached my destination. So first step is going to be, once again, write your givens. That's so important. I can't express, how important it is. It's important to write the first one and also the second one. This tells me where to stop the problem. Without it, students often continue and overshoot the answer even though they've already solved it, okay? The next thing you want to do is choose conversion factors in the middle of the problem. I've chosen 2 good conversion factors here. 3, I want to confirm, do my units grams, cancel out grams. Cancel out means you need to divide by. If I have moles, I need to cancel out with moles as well. Lastly, I want to solve the problem. Here's how I'm going to solve it. Everything on the top is multiplied. 177 times 1 times 6.02 times 10 to the 23rd. And that whole number now, whatever I get from the top, is going to be divided by 12 and also divided by 1. All right, guys, so let's take a second, practice calculating this problem here. Okay, guys, the calculated answer that I have is 8.88 times 10 to the 24th atoms of carbon. All right, now I think you probably got an answer. It's a little different than me. If I'm looking over my calculator, I see 8.8795 times 10 to the 24th. Last thing you need to check out here, okay? Last thing you need to check out. In my original number, you need to count the number of significant figures. And you're like, oh no, significant figures. Yeah, you actually do need to count the number of significant figures. In that problem, 177 has 3 significant figures. Now that's important to me because that tells me in my answer, I also need to see three significant figures. And so I rounded my answer off to have decimal point. It goes like this. 1, 2, 3 sig figs. So 8.88 is what I have. It was 8.88795, and I round that off to 8.88 times 10 to 24th. So just be alert of that. That's something you need to make sure you have. Okay, guys, here's our last problem for the night here. I want to check out this. How many molecules are in 11 liters of oxygen? Okay, how many molecules? And I want you to take this one by yourself. I want you to check this out here. I've left this blank. 1 mole equals so many grams of oxygen. I want you to fill that out yourself. Check it out. If you're stumped, you should try and find out what step you're on. All right, there's 4 steps they gave you. First step is givens, etc., etc., etc. Please use the steps to guide yourself through these problems. Okay, I'm going to solve them. Just come back and check it out. This is the last one of the night, so give it a shot, please. Okay, guys, let's start highlighting here. I have 11 liters of oxygen. That's my given. And I'm going to write that right here. Not just 11, and not even just 11 liters. 11 liters of oxygen. So please include the oxygen in the problems too. Okay, this is dimensional analysis, so I'll have a conversion factor after this. The other thing I need to be alert about is where I'm going to, and the question is how many molecules. So I'm looking, in this case, for something that says molecules at the ending. All right, dudes, so here we go. Let's start the problem off. One thing I will note is that whatever I see right here, liters of oxygen, I do need to see liters of oxygen down below. Now, I'm going to do something a little different here, guys, and I'm also going to say, because I see molecules right here, I know the very last thing I see up here has to be molecules. And it really guides me into what conversion factors I need to choose. I'm going to choose the conversion factor that has the word molecules in it. Yep, I see it right there. And for this one, I'm going to use the conversion factor that has the unit liters. And boom, I know what I need to use now. And in fact, the first one will not even be used. How do I do that? Once again, I see the unit liter here, and I know it has to cancel out with the unit liter down below. And that's why I put it there. Likewise, the very last unit I see that will never be canceled out has to be molecules. And I know that has to appear in the very last one too. So here we go. Let's start filling in the numbers. The liters here, I'm going to use 22.4 liters. And the number that's glued to that, you have to put it down to, is 1 mole. Okay, that's pretty awesome, guys. Liters is gone. We're done. I see the unit mole right here, and I do need to get rid of it, and so I need to see the unit mole on the bottom. All right, well, I'm using the one for molecules, and that number is going to be 6.02 times 10 to the 23rd. That's molecules of O2, and that's going to be per 1 mole of O2. Once again, I chose that number because this number is glued to that number. All right, guys, my problem's done. All I have to do right now is make sure all the units cancel out, and I do. The molecules matches the word molecules over there. Let's solve the problem. The problem to be solved by 11 times 1 times 6.02 times 10 to the 23rd, and divided by 22.4. All right, guys, let's do it. Okay, guys, my calculator is going to give me a number, something like 2.95625 times 10 to the 23rd. So this really should be a 2.96 times 10 to the 23rd molecules. Now, that number is not really a representative of what I need here. I need to make an adjustment to that, and I'm going to write it down here. The reason being, last step, check the sig figs. Over here, I have 2 significant figures. That's kind of important for us in chemistry, actually. My number that I have at the end, the answer, cannot be more significant than the original number we had. So I need to choose 2 numbers here. And the 6 is going to round the 9 up, okay? So what I'm going to end up with here is 3.0 times 10 to the 23rd molecules of O2. Okay? That's how many molecules are in 11 liters of oxygen gas. Guys, that's it for tonight. That's all. I hope it was helpful. Thanks a lot for tuning in. All right, guys, take it easy.